Ellis Bob and Carla are playing a game with tokens. They start with ABC tokens respectfully. The game is played in round before the beginning of each round. They check the number of tokens everyone have. If any two players have the exact same number of tokens, the game immediately ends. Otherwise, the rounds begins. All three players have a strictly different number of tokens. The player with the strictly most tokens gives exactly one token to the player with the strictly fewest token. Given the starting token ABC, determine exactly how many rounds the game will be before it ends. Okay. Round 3 rounds. Okay. So it's just giving 2 to 2. 1 7 10 2 8 8. Why the answer is this answer is 3 actually. Otherwise, the rounds begins. All the players have a strictly different number from the player with the strictly most tokens gives exactly one token to the player with strictly okay, only one. Okay, so 7 and 1 9 plus 3 10. Okay, that's the game. Yeah, makes sense. But did I ruin my snippets? Yeah, I think I ruined my snippets somehow. Somehow ruined my snippets. Something happened. Hope I get this working somehow. Bro, how to disable it? It's ruined. It's giving me solution. What the heck? Bro. How to disable it? What the heck? CVVRs. Correct. It does not work. Yeah, it does not work. Let's see, whatever. It will not suggest me anymore. If it does, I have nothing to say. I'm not gonna participate in the contest actually. It's suggesting me, bro. I have to disable it. Is it an extension? Copilot maybe. What's his name? T0. I have it to be okay now. Yeah, it's good now. Okay, so difference. Three. Four, 6, 1. It gives 2, 5, 4. It gives again. I lost almost 6 minutes just for my co-pilot was suggesting me. I should store them here. Let's f of s be the compressed version of a string s formatted by replacing every maximal contiguous block of identical character with a single copy of the character. For example, f of a bbcc equal to abc. Let's s denotes the length of the be the compressed version of a string formatted by replacing every maximal contiguous block of identical character with a single copy of the character. For example, something. Let's s denotes the length of following f of s denotes the length of the compressed string. For example, okay, if the string is empty, the length is 0. Yusuf has given you a string of consisting of an lowercase Latin letter. You must delete exactly one character true from a new string and find the minimum possible value of f of s. Why it's taking that much time? The compressed version of a string formed by replacing every maximal contiguous block. Okay. Answer is 2. Answer is 1. Yeah. Answer is still 1. Answer is 3. Yeah. Answer is 5. Yeah, makes sense. Okay, got it. The solution is pretty simple. Yes. So I need to see if I remove a prefix, remove a value, does its prefix and suffix are the same value? So I need to find the answer actually first. Lowercase Latin consists of lowercase Latin letter. Okay. In worst case scenario, the answer will not be same actually. S n not equal to s r minus 1. Not equal 7. Answer should be 5 actually. A, B, A, C, A, B, A. Okay. So, okay. Yeah, makes sense. It was gonna do a -2 actually. Failed. 2, 2, 2, 1. Am I printing somewhere else? No. 17. 1. Yeah. Not gonna change. Yeah, makes sense. If yes. Oh. Okay, Yusuf has given you two binary string A and B of the same length, and you are allowed to perform any of the following operation. Choose a substring in A equal to 001 and replace it with 100, or replace or vice versa 011 10010. Okay, choose a substring in A equal to 110 and replace with 011 or vice versa. Okay, your task is to determine whether it is possible to transform string A into B using a finite number of operation. Okay, yes, no question. So I have say 001 is equivalent to 100 and 110 is equivalent to 011. Okay, yeah. So I have to, actually it's more important to know when it's not possible. One zero one zero 0101. Okay. This 0 is fixed. So I want to change the first one. This can be changed to let's say 100, Then the next one can be changed to uh, it doesn't has to be changed actually, 110, and this can be changed to 11000. Was I, which one I did right? I think I got the wrong example. Test 4 was no. Yeah, 01001 10010. Okay, first thing is number of 1 should be same, number of 0 should be same. That's the first thing. So let's try to make them similar actually. If I do 100, this can be in the same place, so 00110, and it can be changed to 1 11000. Again, it's the final form. Then the next one is 01001. Same goes for this one. I can do some operation, take the 1 in the same place, so it can be 0 0 0 1 1, and 1 1 can go in the front, 0 0 0. So those are same, those are same. When it's stuck, I want to know when the operation is gonna get stuck. 1 0 1 0 0 1 0 1. Okay, so yeah, if I wanna do something over here, I can't do anything. I can't do anything, so it's stuck. It's no. It's a new one. 111 0 0 0 111. Sorry. 0 0 0 111. It's a new one. If I select these two, it will gonna be 0 0 1 1 0 1 again, so I can just do 0 0 0 1. Yep, now I can do 1 1. Those becomes 1 0 0. Then I can not do any other operation except because it stays in the middle. Yep, it stays in the middle. It stays in the middle. It's an easy version. Let me see what's easy about it actually. This is easy version. This problem you are only asked to determine whether the string can be transformed into BOK. So yeah. So if I have a pair of ones, I can freely move them if without only 1 0. 1 0 0 1 1 0 0 0 0 0 0 1 1 1. Yeah, I can freely move them. 1 1 1, then 0 0 0 0, and I got the next one, so 1 1 0 0 0 0 1. Now I can freely move it. Yeah, so number of pair of 1 can go in the front easily. Then every one needs at least even amount of zeros in front it. Yeah. I'll try to push every value in the front actually. I think that should work. So let's have 1 0 0 1 1 0 0. Okay, I'm gonna push every value in front. So those are a pair and 0. So it's okay. This position is okay. I'll push them in front to 1 1 0 0. Then again 1. Actually no. If any zeros are in front of any pair of 1, they can go forward no matter what. Okay, and if I have a single 1, it has to have exactly even number of zeros in front of it. That's the main condition, I guess. Yeah. Then I got 1 1. Oh, there's another one condition. There was another condition. Here's CL for now. See a good example. I think it's a good one. Okay, now I have to move the even number of I should do something else actually. So now every single value are at the extreme. This value was already on the extreme. Yeah. So just have to repeat the process. shouldn't. It got a yes. Test is 4. Shouldn't get a yes actually. What happened? Uh, Zero, 1. It got a 1. It shouldn't get a 1 actually. Yeah, it does make sense. So mistake is in here actually. Actually, if I can't move a bill, let's say this one is fixed, so the count will gonna reset from here actually. So yeah, count will gonna get reset. So from this position, nothing can't be changed. So it's wrong stuff. Yeah, I should do that. I should add the ones in front, then for 0. If something like that happens, actually no. Yeah. Let's say I'm adding something, then 0, 0, 0. I have something, and let's say this one can be moved somewhere. This one can be moved. This one can be moved, so obviously I'll move it in front. If the one cannot be moved, it's fixed. It's fixed, so I'll just add the string actually. a plus equal to 1, and number of zeros should be added. I don't need them actually. Number of zeros are stored. Else, if the same stuff else if the same stuff else if the same stuff it will just connect all the zeros. Then we're gonna add the last zero. It's that simple. Then again while yeah, that's simple. One is missing somehow. The fasting was correct. One, two, three. I got an empty string. Okay. Then went for the 0. Got 1. Added 1 directly. Okay. No, it got counted actually. One. Still then 1. Got a 0. Still 1. Then got 1, so got added. Then the last 0 wasn't added somehow. It got 0. What's the wrong? I'm not getting it actually. Why I'm doing the mistake. Zero, 1, got a -1 somehow. That's weird. Got a -1 somehow. I'm doing well. J minus minus. JE minus minus. It should never get a -1. It got 1, then it suddenly became -1. super weird thing. Okay, 1010. Okay, the first thing is fixed. Now the second thing. So let's change the whole thing actually. I'm not gonna take the hits. No. I say failed. Yes, no, yes, no, 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 one extra no. And everything looks fine. Okay, 1, 2, 3, 4, 5, 6. This is the 6. Zero, 1, 1, 0, 0. And okay, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0. It does make sense, they can be converted actually. Just convert it to a function. It's passing. Let's see what happens. Actually, I'm gambling actually. Hmm. 2e5. Hmm. 5 6. Yeah, 10 to the 7. Yeah, I can do up to 10 to the 7. Let's try. Currently, Codeforces is really slow. I think hard version. I should trade hard version. Let's see how it goes. Alright. Wrong. Dang. If it gets wrong, then I'm fully in the wrong side because my solution is faulty. If it gets TLE, it means there might be a way. wrong, this was 1. But it passing in the this was 1. Oh, I submitted in problem B. Okay, my logic is flawed. My logic is incorrect. So I'm doing, if I have a 0, if I have any zeros and any pair of 1s together, Yusuf has a secret array of n strictly positive integer for each element ai. Each shadow bi is the sum of all elements in the array that are strictly smaller than a formally. Okay, you are given the shadow array b. Your task is to reconstruct the lexicular smallest valid array consists of strictly positive integers satisfy the above condition if there's okay. So sum of the all elements strictly smaller than ai. For this one, 0 4 0 4 14. Okay, so no value is smaller than this two. And then all two values are one value or two values are smaller than this two. Then all values are smaller than this two. Am I allowed to use 0? No, 1 2. Okay, so this 2 has to be 1 1. If I think strictly smaller than, actually no. They have to be 2 2 actually. 2 2 and 4, it's 14. 14 is 7 7 7, and it can be 8. Five, 5. Oh, okay. I'm adding those two also. So 5 5, and it can be 6. Let's try another one. It's saying no possible solution. Okay, let's try 0 4 4 4 4 4 9. So I have 4 4s, so it has to be 4, at least 4. Then I have 5 5. 9 by 5 is what? Actually no, 9 minus 4 is 5. 5 by 5 is 1. So putting 1 is impossible, so it's not a valid sequence. I think that should be my, yeah, that should be the correct word of solving it. So first smallest values, I have to count the first smallest values, then the second smallest values, something like that. Sorting it is not fair actually. Find the zeroth position. Previous one, next one. Okay, let me think another thing. No, it's always possible actually. If pre not equal to 1, then I'll do something, otherwise pre equal to uh, pre equal to D. So let's have 4, 4, 4. It has some values. 4, 4, 4. It has some values. Four, 4, 4. It has some values. Set to position. I have two positions. Okay. Let's say previous sum is let's say 2, and I have 4, 4, 4, 4. So 8, I need 6 actually. 6 by 2. It has to be a rational number. True. Total number of positions. No. V minus sum. If need need 0 is possible. Let's say I have 0, 0, 0 and 1, 1, 1. Can be possible, but this thing isn't. Yeah, 0 is impossible. If need greater than 0 and need much pause g dot size equal to 0. Actually, no. I'm saying if need is greater than 0 and need mod some position pz dot size equal to 0, if both equal to 0, it's divisible. If the value is divisible, then I'll do something. For R2 answer V equal to net divided by this thing. Max equal to 0. Also sum plus equal to inside max equal to else P equal to 0. If P P is always 1. That's not normal. It should give me something else. What? There is three different levels. 0, that shouldn't be any 0 actually. I should be answer. Four, one. Yeah. Only 1, 0. Ten thousand solve. Nice. Please don't get one. I don't even wanna see CC. Yusuf has a hidden array A of length and consisting entirely of strictly positive integer, and operation was performed exactly once to create an array B set B equal to A B1 equal to A1 for every I from 2 to n set B equal to AI minus A minus A minus 1. After this, the element of B were completely shuffled. You are given the shuffled array B. Reconstruct the lexically smallest original array if it is impossible for any arrangement of B to product an array. Okay, got the points. So the condition is A1, then is A2 minus A1, then is A3 minus A2, then A4 minus A5, A4, A3, so on. Okay, so I have those values. Let's see example. So I have to construct that 1 1 2 6 4 2. If I do, it will be 1, it will be 0, it will be 1, it will be 4, it will be minus 2, it will be again minus 2. Okay, yeah, same stuff. Okay. There has to be some pattern or something. Minus 2, minus 2, 4. Can I create any kind of array? Minus 2, minus 2, 4, 1, 0, 1. At first negative value is impossible, so any of them has to be the first variable. A has to be greater than equal to 1. So 0 also not a viable option, so 1. Then I got minus 2. Okay, say I got 1. I'm fixing it. Yeah. Then what's the best option? Best option is getting another 1. So let's say get the 0. Means 1 1. Then I got 2. Then I have no option, so I'm gonna have 1. So it will produce 2. Then I wanna have another small value. Let's say minus 2, minus 2, 4. Let me have 4. If I have minus 2, it will gonna produce 0. So 0 is not viable. So it has to be 4. If I add 4, it will gonna be 6. Then minus 2, it will gonna be 4. It will gonna be 4. Minus 2, it will gonna be 2. And yeah, and that's the answer. So if I got any positive I'll try to take the closest one. Closest any one which value is positive, and for the negative side or anything else, Yeah, it does make sense. If the negative value is too high, what will gonna happen? Let's have 4. Have 4, then minus 3 and minus 1. Which one is better actually? If I do minus 3, yeah, minus 3 is always better. So I just have to find the smallest closest element to the negative side or positive, doesn't matter essentially. So I want to find what? I want to find the lower bound. I forget about how to use lower bound and upper bound. Finds the lowest bound of 30. Okay. Yeah. Lower bound greater than equal to, returns greater than or equal to. Yeah. Upper bound always greater. Okay, I actually need the lower bounds. Multi-switch. everything is I've removed one, then again remove one. That shouldn't be the case. I've used a multi token. There is one, makes sense. And I've removed one. Then will is again one. Oh, I haven't updated the previous equal damage. I like the fact I couldn't solve problem C, but I think also you're gonna get accepted. Yeah. It was a really good idea to give up on C and going forward to E and D. So let's do F. Also, I really like the questions. Those are really short and easy to understand. Yusuf has given you an even integer n and two array a and b, both consist of non-negative integer. You can perform the following operation on a any number of time. Okay, choose an index I. Okay, choose an index I for all j such that I not equal to j, replace aj with XOR of that the element ai remains unchanged. Okay, determine whether it is possible to transform array A into array B using finite number of operation. It's giving me a similar vibe from C. So let's see. 1 2 4 7 6 7 5 3. Okay. Let's write them in binary. 0 1 1 1 0 1 0 0 1 1 1 6 6 is 1 1 0 7 1 1 1 5 1 0 1 3 1 1. So I'm gonna make 1 1 0 here. So I have to remove this odd part. Yeah, odd part can be removed. Then I wanna add that even it's little bit, I think it's connected to power of twos. One, I have all power of twos, so I can make any values no matter what is the condition. It's a bad example. Let's take this one. 1 2 4 8. 1 is 1 0 2 0 1 0 0. It is also a bad example. Yeah, 3 5 6 9 10 12. It's 1 1 1 0 1 1 1 0 1 0 0 1 and 1 0 1 0. It's 1 1 0 0. It's also yes. Okay. And under is 1 on 0. 5 is 1 0 1. Then 3 is 1 1. Then 12 is 1 1 0 0. And then 15 is 15 is 1 1 1 1 and 9 is 1 0 0 1. If I want to make here 0, I need any value which is yeah, 1 after that. I want to make 1, so this value becomes 1 0 1 becomes 0 1 1. It just matches. Okay, then it already matched. Then I'll go here and make 1 here, so I'll just add any value with 1. So 1 0 1 1, it becomes 0, it becomes again 0, so it becomes 0 1 0 0. Then I want to make 1 here, so I need 1 1 at the end. For any value I want just 1 1 at the end, so that should be my value. So I'm just finding the exact operation. Okay, should I use a triad or something? How much time I have? At 24 minutes. So I just need to find that exact prefix. So 2 to the 5 into 60. It shouldn't be a problem. Into 30 actually. So it shouldn't be a problem. It's not that simple. Values are getting mutated. Can I make some power of 2s? That's my main question actually. all of them some power of 2's, all of them equal to 0. If I want to make it 0, one one. I need exact 1 1. I'll get 6, then I can use that one. With some operation, I want to make them 0. If I have them, I want to add exactly 30 values. So in every position there is odd, even amount of ones. Okay, I want to make that even amount of words. See the standing actuators, why not? 7,000. Bro, everyone solved up to E with C1, C2. Should I try C1, C2 again? Yeah, I should give a try, another try. So A, B. Or it's just always easy to put the values on the middle. Then if I got this kind of block, so 001, only 001, my logic wasn't correct. 1001100 000 1 0111. Okay, I have those values. I'm gonna make the values in a similar format. Let's do another thing because I don't have enough time. Nice. Reverse. There's still a huge possibility that you're gonna get wow. So let's now there is a good chance. This will got reversed. 1 2 3 4 5. Just 5. They shouldn't never be equal. Dang. Yeah, those are not equal. So why? Okay, it's actually giving no. So one discuss two. Reversing. Okay, reversing is not valid always. Let's give it a try. Most probably it is gonna get one. If it gets accepted, it's gonna get hacked. So that's that. Standing looks steady. This value is fixed position, can't be changed, and this value can go in from here, so they're okay. Then these two can pair up, and these two can pair up. No idea. Okay, 8 minutes left. I don't think I can solve it, so let's end it actually.